Welcome back. We're going to do deductive reasoning today. And so think about this. We've already done inductive reasoning, which is where we took patterns and small sets of information and we made these large conclusions. So with inductive reasoning, we're taking something small and making these broad conclusions. Deductive reasoning, I want you to think, is the opposite. We're taking all these facts and we're drawing a conclusion. So we are deducting that information. So if you want a definition here, it is the process, I'll write that down, the process of reasoning logically and drawing a conclusion from given facts and statements. Okay, there's my definition. So if we're given a conditional statement, if the hypothesis is true, then the conclusion is true. Now, when we think of hypothesis and conclusion, immediately I should start thinking of the symbols P and Q. So the symbolic piece to this, so the symbolic piece is if P, then Q, right? And the difference here is that the law of detachment says P is definitely Q. P is definitely true. So before we were making our own assumptions, but now law of detachment says if P, then Q, if your hypothesis is true, P is true, therefore, these three dots mean therefore, then Q has to be true. Okay, so let's look at some examples that would look like. Let me erase this. Oh, look, and it still doesn't work. Okay, all right, let's try it again. Okay, there we go. All right, so know what I'm saying. If the hypothesis is true, the conclusion is true. All right, so let's see if we can use the law of detachment. If it's not possible, we're going to write no valid conclusion. Joey, I'm just reading these out for you because I know sometimes you struggle with reading. Just teasing. Okay, so if Mark saves $30, so that's my P statement. My conclusion is he can buy a new video game. Mark saves $30. Therefore, what can we conclude? We can conclude that Mark can buy a new video game. Pretty simple, right? All right. So, if a quadrilateral is a rhombus, that's my hypothesis, then it is also a parallelogram. Quadrilateral ABC is a rhombus, which is what my hypothesis says. Therefore, I can conclude that it is also a parallelogram. Okay, so I'm going to give you a second to write that down. Let's look at some other statements. Okay. My hypothesis. If you're 18 years old, then you can register to vote. Olivia is not 18 years old. What's my conclusion? You don't have a valid conclusion. You can't make assumptions. It's only if this statement is true. If you are 18 years old. Olivia is not 18 years old. So I can't make any conclusion. So there is no valid conclusion to be reached there. All right. Okay, next one. If the sum of the measures of two angles is 90, then they are complementary. Angle J, the measure of angle J is 58 degrees, and the measure of angle K is 32 degrees. So the sum, if their sum is 90 degrees, their sum is 90 degrees, now I can say they are complementary. So my conclusion is they are complementary angles. All right, let's look at our next one, number 5. If you plan to attend prom, then you must purchase a ticket. So I'm looking for P. P is my hypothesis statement. If you plan to attend prom, then you must purchase a ticket. Sarah purchases a prom ticket. That's not my hypothesis. That's my conclusion. But remember, law of detachment says if P then Q, if P is true, then Q is true. Well, this says Sarah purchase a prom ticket. No valid conclusion can be reached because I'm looking for P to be true. I can only jump to that conclusion if P is true. So no valid conclusion. No. Okay, so that's law of detachment. So it's really kind of simple when you look at it in that symbolic math. If P then Q, P is the one that must be talked about. So in this statement, P is not being talked about. P must be talked about. And if P is true, therefore Q is true. Okay? All right. Law of detachment. That's what it was. Now we have law of syllogism. Okay. So, law of syllogism allows you to draw a conclusion from two conditional statements in which the conclusion of the first statement is the hypothesis of the second statement. And actually what I'm going to do is I'm going to stop this video and make another one just for law of syllogism, so you can go back and forth between law of detachment and law of syllogism.